Asterisco asterisco intro asterisco asterisco. The deeper we dive into space, the more incomprehensible and hostile it becomes to live. Sometimes even hypothetical space monsters are not as frightening as ordinary planets. A Neptune-like gas giant will leave no trace of humans with its constant rain of glass, while two zombie planets orbit a long-dead star in the constellation Virgo, suffering from radiation every day. Today, we're going to take you on a short journey to planets that you would hardly want to visit in reality. HD 189733b. The first planet in line is the blue gas giant HD 189733b. It's slightly larger than Jupiter, but unlike the largest planet in the solar system, HD 189733b is only 2,900,579.8 miles away from its star. For comparison, the distance between Jupiter and the Sun is almost 166 times greater. Therefore, one orbital period of HD 189733b around its star takes only 2.2 days with an orbital speed of 134,000 miles per hour. The star around which the gas giant is moving is a K-type star or orange dwarf. Such stars have lower temperatures than, for example, G-type dwarfs like our Sun, but they have a longer lifespan. These factors make these stars very promising for the development of life on planets in their systems. But the planet we're telling you about is definitely inhospitable to any life forms we know. HD 189733b is too close to its star. According to various sources, the giant's temperature reaches almost 2,000 degrees Fahrenheit, so it belongs to the class of hot Jupiters. In particular, it can be turned only one side to the star, but according to the Spitzer telescope, despite this, its surface still has a fairly high temperature around the perimeter. But that's not the only reason why HD 189733b is a life-threatening planet. I wonder why this planet is completely blue. Another gas giant, Neptune, as far as you know, has the same color because of its dense methane clouds. However, although there are traces of methane on HD 189733b, it's too hot for the gas to condense into clouds. In particular, there's no water there, only water vapor. So, why does the gas giant have a similar color? This blue color of the planet is probably due to its strange atmosphere, which has reflective silicate clouds that form droplets of glass. On HD 189733b, it rains small glass particles, moreover, along the horizontal. However, remember the planet's rotation speed. Because of this, its winds can reach almost 6,000 miles per hour. Superfast storms on HD 189733b with glass impurities could cause fatal harm to humans and very serious damage to other matter. So, the weather on this gas giant is dangerous, to put it mildly. In addition to glass storms and high temperatures, HD 189733b is also very strongly irradiated by its star. The planet loses 100 to 600 million kilograms of atmosphere per second. Therefore, it's unlikely that anything would be able to survive on this deadly planet from all sides. 55 Cancri E and K2-141b. You've probably seen images of hell before, a hot and creepy place filled with lava uncovered in black soot. The next two planets, 55 Cancri E and K2-141b, can confidently claim to be real hell worlds with oceans of lava on their surfaces. 55 Cancri E is a rocky planet almost 8 times the size of Earth. It orbits at a distance of only 1,394,337 miles around a calm and rather cold red dwarf located 41 light-years from the Sun. It is the closest planet in the system. In addition to it, there are 4 other confirmed planets. All of them are gas giants, which are also very close to their central star, except for the last one, 55 Cancri D. A year on 55 Cancri E lasts only 18 hours, and only one side of it is likely to be irradiated. Thus, the temperature of its side facing the star can reach an average of 4,200 degrees Fahrenheit, and the unlit side averages from 2,400 degrees Fahrenheit to 2,600 degrees Fahrenheit. However, Alexis Brandeker, a researcher at Stockholm University, has noticed that the hottest spot is moving and the temperature around it is varying. He concluded that the planet may be in resonance with its star, which means it has a day and night cycle. However, the ultra-high temperature of the illuminated side indicates that this part of the planet may be molten and thus completely covered with a layer of lava. It is not known for certain whether the alleged night side is covered with lava. According to astronomer Renu Hu, the entire planet should be covered with lava. Moreover, 55 Cancri E most likely has a dense atmosphere that can hide layers of lava. It consists mostly of the same elements as Earth's, mostly hydrogen, helium, as well as nitrogen and oxygen, but no traces of water vapor have been found there. So, if this planet can have an atmosphere and still be in resonance with it, then it can cool down. But then this hellish world becomes even more dangerous. If the silicate surface heats up and evaporates during the day, then the vapor would cool down overnight and, like on HD 189733b, would create some precipitation, namely lava drops. Add to this the very fast movement of the planet around the star, and we get the likely hot storm with lava rain. Finally, such proximity to the star can cause volcanic activity on the planet, which can also increase the planet's temperature by blocking heat emissions. K2-141b is also a rocky planet that orbits the orange dwarf at a distance of 202 light-years. It's almost 5 times larger than Earth and also has a density of 1.5 times more, but it moves at an even smaller distance from the star than 55 Cancri, 694,379 miles. Therefore, 1 year on this planet lasts only 7 hours, making its orbital period one of the shortest known at the moment. The hellish winds can reach speeds of 5,000 miles per hour there. The planet is most likely blocked by tides. Its illuminated side can have a temperature of 5,430 degrees Fahrenheit, while at night, the temperature drops to -328 degrees Fahrenheit. Likewise, the daytime side is completely covered by lava ponds at depths of more than 62 miles. Moreover, like our Earth's oceans, K2-141b has a similar magma cycle. The silicate rocks vaporize and fly at supersonic speeds to the cooled side, where they condense and return to the hot side and fall out as pebbles down, where they evaporate again, forming a thin layer of atmosphere and keeping the lava in balance. This is very similar to the weather on the previous planet, but because K2-141b is blocked, its precipitation is timed to cool and therefore falls as rocks rather than lava. However, some studies indicate that the flow of minerals back to the illuminated side may be too slow, which could theoretically create an overload on one side and change the planet's rotation on its axis. Thus, the atmosphere of K2-141b consists of solid elements, sodium, sodium oxide, or silicon dioxide, meaning it has the same composition as the surface. Our Earth probably looked like this at the beginning of its formation, but it's highly doubtful that these two planets will ever be able to give any life a chance to develop. Kepler 70b. However, 55 Cancri E and K2-141b both pale in comparison to the theoretical Kepler 70b, a rocky planet that's hotter than the Sun itself. Kepler 70b, or KLI 55b, is probably 4,200 light-years away and orbits an incredibly hot, dying star with a temperature of 49,452 degrees Fahrenheit. Kepler 70b is almost half the size of Earth, but its density is similar to that of Earth. According to the study of astrophysicist Stefan Charbonnet, this planet may be only 557,734 miles away from the star. Therefore, the planet's surface could be around 12,000 degrees Fahrenheit. It's impossible to say exactly what the planet might look like because of the difficulty in studying it, but only part of the fried core may likely be visible from under that destroyed surface. It could have been a gas giant before, but it lost its shell. There's also another planet in this system, KY 55c, which is probably also rocky. They may be in a 3:2 orbital resonance, which could explain why they probably still exist. However, this is not the strangest and scariest thing that's happened to this planet. As the central star is slowly dying, it's already past the red giant stage, the stage of star death, when the thermonuclear fusion of hydrogen in the envelope begins due to the end of hydrogen reserves in the core. During this phase, the star begins to grow and absorb nearby planets, and since Caeli 55b probably continues to move around the star, it has most likely spent some time inside its dying star and survived. When the planet, hypothetically a gas giant at the time, was inside, it could have completely lost its gas and liquid envelope, which is why it has that scary half-dead appearance. In addition, it may be evaporating due to the influence of its star, so maybe the planet doesn't have much time left. So far, the existence of both planets has not been confirmed, and the signals from this system received by the Kepler telescope are interpreted differently. TOI 849b. Proximity to one star is rarely favorable for the planet itself or possible life there. Another planet, TOI 849b, is also most likely the core of a gas giant in the orbit of a yellow dwarf. This planet was discovered not so long ago, only in 2020, by the TESS telescope at a distance of 730 light-years from Earth. The star TOI 849 has a surface temperature of 10,000 degrees Fahrenheit, and the temperature of TOI 849b itself can reach 2,900 degrees Fahrenheit. The planet is 3.4 times larger than Earth, but its mass is almost 40 times greater. So, the density of TOI 849b is comparable to the density of our planet. However, it orbits very close to its star, at a distance of 1.5 million miles. 1 year on TOI 849b lasts less than 1 day. This planet, like the previous one, is only the core of a dead gas giant. It is likely that TOI 849b lost its shell at the formation stage, or even during its stay in orbit. The second option seems to scientists the most plausible since the core may have lost its envelope in the gravitational interaction with the star. Another possibility is that the planet did not reach the mass necessary to retain its shell. It is believed that the critical mass of such a planet should be 10 Earth masses, but the mass of the core is 39 Earth masses, so it must have been much larger than it is now. In any case, TOI 849b is definitely dead and completely covered with rocks. The remnants of the atmosphere are present, but they're scarce. Among other things, the orbit is so close to the star that any atmosphere would most likely have evaporated almost immediately after the planet's formation. If this shell, for example, was made of hydrogen, it could have been attracted by the star, so most likely there are only hydrogen-helium vapor residues, as well as water vapor residues. However, researchers at the University of Warwick think the planet could still exist for billions of years, despite its proximity to the star. So, this planet could also have had the chance to be as beautiful as Neptune, but now it is just as inhospitable. PSR B1257 plus 12b and PSR B1257 plus 12c. In the 90s of the 20th century, mankind had its first opportunity to make sure that there really were other planets outside the solar system. But it was unlikely that anyone could have imagined that the first known exoplanets could have turned out to be the least suitable planets for life. These were the two zombie planets, PSR B1257 plus 12b and PSR B1257 plus 12c, orbiting a pulsar in the constellation Virgo, 2,300 light-years from Earth. The planets are only 4 times larger than Earth and 1/6 larger, but their mass is 0.02 times and 4.3 times larger than Earth's. These two bodies are most likely rocky planets with a fairly dense structure. Both planets orbit the pulsar PSR B1257 plus 12 at a distance of 41 million and 52 million miles, which is equivalent to the orbit of Mercury in the solar system. Their distance is quite close for a pulsar. A pulsar is a fast-rotating neutron star with a very strong magnetic field that emits radiation, so most likely any atmosphere on these two planets is already missing. PSR B1257 plus 12 itself is a dead star that appeared after a supernova explosion. Scientists suggest that planets could exist before their star died, but they were unlikely to survive the explosion and therefore could have formed again after the pulsar appeared. Thus, they are dead planets orbiting a dead star. Conclusion: there's a possibility that these terrible planets could have been full of life billions of years ago, just like our Earth. But now, they are barely survivable celestial bodies, reminiscent of their past glory.